A parasite in the brain sounds like something invented for horror fiction, but it is terrifyingly real. Around the world, certain parasites can cross into the central nervous system, form cysts inside brain tissue, inflame blood vessels, trigger seizures, alter pressure inside the skull, and in some cases kill with shocking speed. What makes brain parasites so disturbing is not just where they live, it is what they turn the brain into. The organ that controls memory, movement, vision, personality, and survival can become a feeding ground, a hiding place, or a battlefield. Some of these parasites settle quietly and remain hidden for years. Others attack so aggressively that symptoms can spiral in a matter of days. Major medical sources describe several important parasitic diseases of the nervous system, including toxoplasmosis, neurocysticercosis, and cerebral malaria, while broader neurology references note that parasites and protozoa can be among the causes of serious brain infection. To understand how disturbing these infections can become, it helps to begin with the ones that may stay hidden at first, then move step by step toward the parasites that can flood the brain with inflammation, swelling, seizures, and rapid neurological collapse. Because once a parasite reaches the brain, the danger is no longer just infection. It is what happens when something alive enters the most important organ in the human body. Level 0. Silent brain cysts. The mildest and most deceptive level is the one a person may not even notice at first. Some parasites can reach the body and remain quiet for long periods, creating hidden infection without immediate dramatic symptoms. One of the best-known examples is Toxoplasma gondii, a protozoan parasite that infects warm-blooded animals, including humans, and causes toxoplasmosis. In many people, infection causes no symptoms or only mild illness, but the organism can persist in tissue in a latent form. That hidden persistence is what makes it so unsettling. The parasite may not be gone, it may simply be waiting. This level is disturbing because the brain can already be involved without the person realizing it. In healthy people, latent infection may remain controlled by the immune system. But the idea itself is chilling. A microscopic organism enters the body, spreads, and can remain enclosed in tissue for a long time. No violent scene, no obvious collapse, just a hidden biological presence in the background. That is what makes silent parasitic brain infections so unnerving. The threat is not always loud, sometimes it is invisible. Level 1. Cerebral toxoplasmosis. The next level begins when that hidden infection is no longer quiet. Cerebral toxoplasmosis happens when toxoplasma affects the brain more directly, especially in people with weakened immune systems. The CDC notes that toxoplasmosis can be severe in immunocompromised people, and neurology references listed among the important parasitic infections affecting the nervous system. When the parasite becomes active in the brain, it can cause headaches, confusion, fever, poor coordination, seizures, and focal neurological problems depending on which areas are affected. What makes cerebral toxoplasmosis especially disturbing is how easily it can masquerade as something else at first. A headache may not sound terrifying, a little confusion may seem vague, but inside the skull, the parasite can be producing inflamed lesions in brain tissue. The person is not just sick, their brain is under attack, and because the brain controls everything from movement to speech to awareness itself, even a relatively small lesion can create major symptoms. A parasite only has to damage the wrong area to change how a person thinks, moves, or survives. This is the point where the concept of a brain parasite stops sounding abstract and starts becoming medically brutal. The infection is no longer just in the body, it is now interfering with the nervous system directly. Level 2. Neurocysticercosis. At this level, the parasite does something many people find even more horrifying. It forms cysts in the brain. Neurocysticercosis is caused when the larvae of Tinea solium, the pork tapeworm, enter tissues such as the brain after a person swallows tapeworm eggs. The CDC explains that when these cysts are found in the brain or central nervous system, the condition is called neurocysticercosis. The WHO also identifies cysticercosis as a major parasitic disease, and CDC material describes neurocysticercosis as the most severe form because it can lead to seizures and can be fatal. This is one of the most disturbing brain parasites because the image is not metaphorical. The parasite's larval cysts can literally lodge in brain tissue. In some people, the first sign is seizure. In others, it may be headaches, hydrocephalus, confusion, or signs of increased pressure in the skull. Sometimes the cysts remain for years before the immune system reacts strongly to them. That delayed reaction can make the disease even more deceptive. A person may feel fine for a long time only to develop major neurological symptoms later when inflammation rises around the cysts. What makes neurocysticercosis especially important medically is that it is one of the most common parasitic infections of the central nervous system worldwide. Review literature and public health sources consistently identify it as a major cause of neurological disease and seizures in affected regions. That means this is not just a bizarre medical curiosity. It is a real and significant brain disease caused by a parasite that can turn the brain into a host organ for larval cysts. Level 3. Cerebral malaria. At this stage, the parasite does not need to form large cysts to become terrifying. It can instead disrupt the brain through the bloodstream itself. Cerebral malaria is one of the most severe complications of malaria, usually associated with Plasmodium falciparum infection. MSD notes that malaria can cause confusion and seizures among its serious manifestations, and review articles on parasitic infections of the nervous system identify cerebral malaria as one of the major parasitic infections affecting the brain. What makes cerebral malaria so disturbing is its speed and scale. This is not a parasite quietly hiding in one corner of the brain. It is a blood-borne infection affecting the brain through widespread vascular and inflammatory damage. A patient can develop fever, confusion, seizures, coma, and rapid deterioration. The brain is not just hosting a parasite. It is being caught in a systemic assault where infected red blood cells, inflammation, and impaired circulation can all contribute to neurological injury. This level feels especially frightening because the brain can be overwhelmed even without a visible worm or cyst. The parasite does its damage through circulation, inflammation, and the catastrophic effects of severe malaria on the nervous system. And from here, the brain parasites only get even more horrifying, because some of the next ones invade fast, destroy tissue directly, or lead to rapid and often fatal brain swelling. Level 4. Rat lungworm in the brain. At this level, the parasite is no longer just disturbing because it reaches the brain. It becomes disturbing because it physically migrates there. Angiostrongylus cantonensis, often called rat lungworm, is a parasitic nematode that can cause severe central nervous system disease in humans. CDC states that the most notable manifestation is eosinophilic meningitis, caused by the presence of larvae in the brain and the body's local reaction to them. Symptoms can include severe headache, nausea, vomiting, neck stiffness, seizures, and neurologic abnormalities. What makes this parasite especially disturbing is the idea that the symptoms are being caused not just by infection in general, but by larvae actually reaching the brain. The nervous system becomes inflamed because something living has entered tissue it should never touch. In some patients, the illness is self-limited, but CDC also notes that A. cantonensis infection can occasionally be fatal. That makes this level much more than a strange parasitic disease. It is a real neurological threat. Level 5. Gnathostoma in the nervous system. At this stage, the parasite becomes more unsettling because of the way it moves. Gnathostomiasis is caused by larvae of Gnathostoma species, and humans are accidental hosts. CDC materials note that central nervous system involvement is a dangerous complication, and CDC's Emerging Infectious Diseases Journal describes this form as being associated with painful radiculopathy, eosinophilic meningitis, and even paraplegia in some cases. What makes this parasite so disturbing is that the larvae do not simply stay in one place, they migrate. CDC literature explains that visceral disease can involve the central nervous system, and published reports note mortality rates of roughly 8% to 25%. In visceral gnathostomiasis, with tissue damage linked to both mechanical injury by the larvae and the substances they release. That means the damage can come from the parasite physically moving through tissue as well as from the inflammation it leaves behind. Level 6. Raccoon roundworm in the brain. This level is where the script starts feeling less like medicine and more like nightmare biology. Balamuthia procyanus, the raccoon roundworm, can cause neural larva migrans when larvae invade the brain. CDC describes B. procyanus-associated neural larva migrans as potentially life-threatening, with the usual presentation being eosinophilic meningoencephalitis and severe neurological signs and symptoms. Recent CDC reporting also notes that some cases have been fatal. What makes Balamuthia especially horrifying is that its larvae can continue migrating through tissue instead of stopping neatly in one place. The brain is not just infected, it is being invaded by larvae that can keep moving and damaging tissue as they go. CDC's recent MMWR reporting highlights prolonged migration and persistence of these larvae in the brain as one of the serious complications. This is the kind of parasite that turns the brain into a path of destruction rather than just a site of infection. Level 7. Neural larva migrans from other parasites. At this point, the horror becomes broader. Some parasites do not get as much public attention, but they can still invade the central nervous system and cause devastating disease. One example is Toxoplasma, better known for toxoplasmosis. CDC notes that migration to the central nervous system, sometimes called neurotoxoplasmosis or neural larva migrans, is uncommon but can cause eosinophilic meningoencephalitis, and severe neurologic involvement can be fatal. What makes this level disturbing is the pattern itself. A larval parasite enters the human body by accident, fails to complete its normal life cycle, and instead wanders through tissues where it does not belong. If that wandering reaches the brain, the result can be swelling, inflammation, neurological symptoms, and permanent damage. It is a reminder that for some parasites, the brain is not a target in the usual sense. It is collateral damage from a larva lost inside the wrong host. Level 8. Balamuthia brain infection. At this level, the parasite becomes even more disturbing because the brain infection is usually slow, deceptive, and overwhelmingly deadly. Balamuthia mandrillaris can cause granulomatous amoebic encephalitis, or GAE, a rare but nearly always fatal brain infection. CDC notes that symptoms can take weeks to months to appear, which makes the illness especially dangerous because it may not look catastrophic at first. Early symptoms can include headache and fever, while later symptoms can progress to confusion, trouble walking, and other severe neurological problems. What makes Balamuthia so disturbing is that it does not always announce itself with a sudden collapse. It can build quietly, spreading from the skin or other parts of the body into the brain, while the damage keeps growing in the background. By the time the brain is clearly involved, the infection is often already extremely serious. CDC's clinical guidance says that even when patients with Balamuthia GAE are treated, most do not survive. This level feels terrifying because of how hidden it is. A parasite enters the body, spreads slowly, reaches the brain, and causes a lethal infection that can look vague at first and devastating later. It turns the brain into the site of a long, creeping neurological attack. Level 9. Naegleria fowleri. At the highest level is the parasite-like organism that may be the most infamous of all. Naegleria fowleri, often called the brain-eating amoeba. It causes primary amoebic meningoencephalitis, or PAM, a rare brain infection that is nearly always fatal. CDC says symptoms usually begin about 5 days after exposure, though they can appear anywhere from 1 to 12 days, and the disease progresses rapidly. In the United States, CDC reports that between 1962 and 2024, there were 167 reported cases and only 4 survivors. What makes Naegleria so horrifying is its speed. Unlike parasites that may stay hidden for months or years, this organism can move from exposure to catastrophic brain destruction in a matter of days. CDC notes that infection happens when water containing the amoeba goes up the nose and reaches the brain. Once there, it causes rapid inflammation and tissue destruction. Symptoms can begin with headache, fever, nausea, and vomiting, then quickly progress to stiff neck, confusion, seizures, hallucinations, coma, and death. A recent CDC case report also described a fatal infection where the patient deteriorated and died just 3 days after hospital admission. This is the final level because there is almost nothing more disturbing than a brain infection that is both incredibly rare and overwhelmingly lethal, moving so fast that the brain can be destroyed before doctors even have time to fully identify what is happening. At this point, the parasite is not just living in the brain, it is overwhelming it. From silent cysts to migrating larvae, from seizure-causing brain lesions to nearly always fatal amoebic infections, brain parasites reveal some of the most disturbing ways the human nervous system can be invaded. They are terrifying, not just because they infect the brain, but because they turn the body's most protected organ into a place where something foreign can hide, move, grow, and destroy. Thanks for watching.